Hi there. I know learning programming is such a tedious and intimidating job. It requires a lot of practice and patience. However, I am Sam and we are going to talk about Programming for Dummies 101. And we are going to uncover the basics of the C++ language for today. We will be joined by my partner in type as she explains what are the different data types for our first topic for today.
Let's start out by learning the basics. In C++, we have what we call primitive data types. These are known as the basic building blocks of data in a program. While there is a lot of primitive data types, today I will only discuss 5 because I get that it can be really confusing sometimes. And let me tell you, these are the basics of the basics. It's int, float, char, string, and bool. Now, you may be thinking, what are these? It's basic. First is int. It is used for the value that are whole numbers. No decimal points, just number itself. Float is the opposite of int, as it tolerates number with decimal points. Char, on the other hand, caters values that are merely letters, while string is best used for values composed of words, and bool is true or false. Just basic, right? Once again, int for whole numbers, float for numbers with decimal points, char for single letters, string for words, and bool for true or false. Just always keep in mind that they are needed for declaration and initialization of the program. And always remember, your C++ would not work without these. Now, let's do a sample program. Let's say I want to display the number 7 on my program. What we're going to do first is identify what data type best used for the value of 7. 7 is a whole number. And based on what we learned earlier, int is what we use for whole numbers. So we're going to use int. Now that we identified what primitive data type we should use, let us now declare. To declare, we're going to type the data int and the variable, let's say x, and put a semicolon after it. Now let's initialize. So we're going to put the value on x, which is 7. So we're going to type x equals 7 semicolon. To make things easier, we can always declare and initialize together. Now let's combine and we just have to put int x equals 7, then semicolon. Now, let's see if the program would work. Let's see out x semicolon and try to run the program. See? It's just easy. Just always keep in mind what type of data you should use and declare accordingly. Now, I want you to remember a few things. First, when the data type is char, use a single quotation. For example, char x equals single quotation a semicolon. Second, when the data is identified as a string, we use a double quotation. For example, string x equals double quotation program, then semicolon. Did you get it now? Just easy, right?
And that is it for data types. I guess we are never really escaping mathematics even in programming because we will now be learning arithmetic operators and comparison operators in basic programming. Just like the normal operations in mathematics, we also have addition operator. Basically, we use it to add the value of two numbers and get the sum of these values. We also have the subtraction operator. We use it to know the difference between two values. If you want to know the product of two numbers, we use the multiplication operator, which is an asterisk. And meanwhile, our division operator uses a slash symbol to get the quotient of two numbers divided. We can also get the percentage between the two values with the help of a modulus operator, which uses the percentage symbol. Now let's try using it in our program. Say, you want to get the sum of 2 and 3. Since we're looking for the sum, we are of course going to use the addition operator. Using int, since two values are whole numbers, the code should be as follows. We must declare our value was first. Int a is equals to 2, semicolon. This is our first value. Int b is equals to 3, semicolon. This is our second value. And int c, semicolon. C is equals to the value of A plus the value of B, semicolon. C out, ENDL, and semicolon. Now, let's try doing the same process but with multiplication operator. Let's multiply 38 and 7 using our multiplication operator. Int I equals 38, semicolon, int Q 7. Try it with yourself. Let's try. Voila! You now have the product of two numbers. Easy peasy lemon squishy. So, after operators, we are now going to talk about the if-else language of C++. So, I'm just going to call on my other partner in time, Azrael de la Cruz, to talk about the if-else statement. So, partner, are you there?
Now, we're going to explore one of the most important programming structures, the if-else statement. What is an if-else statement? If-else statement is like a decision-making tool for your program. It helps you to tell your program what to do under certain conditions. Sounds fun and interesting, right? But what do I mean by decision-making? Let me explain. Imagine you are standing outside and you want to decide whether to wear a jacket or not. So first, of course, you'll check the weather condition. If it's cold, you wear a jacket. If it's not, or if it's warm or hot, you don't. This is exactly what an if-else statement does in programming. You check a condition, and based on that, you will make a decision. Let me show you the basic syntax of it. As you can see from its simple syntax, you are essentially telling your computer, if this condition is true, do this. Otherwise, do something else. Let's dissect it now. There are two possible outcomes for the condition, which are true or false. Based on that, it determines whether the program will jump to the action after the else or follows the first action after the if. For example, let's say we check if a number is positive or negative. Let's write a program that checks if a number is positive or negative. Here's our basic structure. In this case, if the number is greater than 0, it prints the number is positive. But what happens if it's less than 0? When the number is less than 0, the program will do the else part and show the result, which is the number is negative. But there is something that we must also consider, and that is, what if the number is 0? Regarding this, we need another condition to handle 0. So we will add an else if statement. The else if allows us to check another condition if the previous ones weren't true. So let's add that to our code. Now, if the number is exactly 0, it will print the number is 0. The if-else structure is super flexible, and you can do layers of conditions within each other to make more detailed decisions. And don't forget, every if, else if, or else is just a part of a bigger structure that guides your program's flow. If you keep on practicing it, you'll master this program structure in no time. If you ever get stuck, just remember that it's all about decision making based on conditions. Happy coding!
Now that we've learned about primitive data types and the if-else statement, let's now talk about program control structures. But what is repetitive structure? Its simple repetitive structure allows us to execute a section of code multiple times. For example, if you want to say hello 100 times, instead of spending many minutes and typing it one by one until you get into 100, you can simply use the code and it would do it for you. So it's very amazing, right? Here we use a for loop statement with the syntax for curly bracket and the code to be executed. Let's dig deep into the details. The for is the foundation of the for loop statement. The program would not really work without it. Initialization simply initializes the loop control variables as seen in our previous programming for dummies lessons. It puts value onto a variable. The condition part, on the other hand, evaluates if the iteration is true. If true, the program will loop just perfectly. The increment slash decrement part updates the loop control variable after each iteration. Take note that each iteration refers to one loop run. Now that we have learned about the syntax, let us now run a simple for loop program. Say we want to say hello world 1,000 of times. We're going to type for parenthesis I equals 1 as our base, semicolon, I is less than or equal to 1,000 since we want 1,000 loops, semicolon, I plus plus is our increment, parenthesis. We are then going to put a curly bracket and see out hello world and close it again with a curly bracket. And we're done. We just need to run the code and there you have it. Thousands of hello worlds without having to type it one by one. Reminder, never ever put a semicolon after the for line. Learning this, you'd never learn how to just work hard, but you just work smart and run a program that will do things for you. So that concludes our for loop statement. Let's now go on to the next topic.
To further your knowledge in creating a repetitive structure, we are now going to learn how to do a while loop. Just like with for loop, we can also execute a multiple block of codes with while loop. Start learning the syntax of while loop to easily understand how to execute. While parenthesis, condition. Curly bracket, code to be executed. Curly bracket. Now, that we learned the syntax of while statement, let us now learn the details of this loop. While is the foundation of loop and evaluates the condition. If the condition is true, then the code will run. But if the condition is turned out false, the loop will terminate and the code executed will not run. For example, if we want to count 1 to 100 and do not want to manually type it, we can use a while loop. Remembering the syntax, the code goes in count equals 1 because our loop will start from 1. Take note to always declare and initialize our variables first or else the code will not run. Then we type while, then open parentheses, the condition of the code, which is count, then less than sign, equals sign, and then the limit of our loop, which is 100. Then put curly bracket. Here's the fun part. We will now execute the code needed to display our output with count, less than sign, count, less than sign, count, less than sign, and L. After that is our increment, which is count plus plus. Remember that in while loop, the increment is separated from the code execution of while statement. And then finish it up with another curly bracket. Then run your code to do tests. To test if the condition is true. Your code should look like this. In count equals 1, while parenthesis count less than sign equals 100. Curly bracket, C out, less than sign, count, less than sign, count, less than sign, and L. Count plus plus, then curly bracket. Always remember not to put a semicolon after our while statement. Did you enjoy learning the while loop? Now, let's learn do while loop. It is a variant of the while loop, but the difference is that the body of the loop is executed once before the condition is checked. Its syntax is written like this: do curly curly bracket code to be executed curly bracket while parenthesis condition. In this loop structure, the do statement is our pretest to evaluate if the condition is true. Meanwhile, the while statement becomes the post test to evaluate the condition. Meaning, no matter if the condition is true or false, the loop is sure to run at least once. Let's take the program we use for the do while. We are going to declare int count equals 1. But instead of typing a while line after, we're going to put do first. Do curly bracket C out less than sign count less than sign count less than sign and L. Do not forget the increment count plus plus. Close it off with a curly bracket. And then finally do the while condition. While parentheses count less than sign equal sign 100. Let's run the code now. Now, this code is this code loop just perfectly as the condition was true. But what if it's not? Let us change the while condition. Count less than sign equal sign 100 to 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 while count to while parenthesis count greater than sign equals 100. You see, this is a false condition as 1 is definitely not greater than 100. Let's see what will happen if we run this. It is work, but the loop only ran once, as then again, a do while statement ran at least once, even if the statement is false.
And that is it. That concludes our topic and our lesson for the C++. So I will just see you again when you need another lesson for programming. But for today, that's all. Again, we have talked about the C++ language. So never forget the things that you have learned here because you're going to need it in the near future. So I'm pretty sure you are tired. So let's us rest and wrap it up. Thank you. And again, this has been Sam, and this is the Programming for Dummies 101. Bye.